Alright, so this video we're going to be talking about Lewis structures. But first we're going to look at what molecules are. Now, as a review, we have just in the last 9 weeks we talked about ionic and covalent compounds and how that atoms share electrons or transfer electrons to form bonds. But what are these? When you have a covalent compound, two nonmetals share electrons, and that's what we're going to be looking at is covalent compounds and their molecules and the shapes of their molecules. And this is an example right here of BF3, which is boron trifluoride, and this is one molecule of it. If you had a sample of this, it'd have millions of molecules, and one individual molecule would look something like this in this shape anyway. Now the middle atom there is boron, and then you got 3 fluorines around it, and it forms a certain shape that we'll be talking about later on. But these white lines there are the bonds that are formed, and those white lines stand for shared electrons. It's actually not a line that's connecting these atoms, it's an electrostatic attraction that keeps these atoms close to one another, and because they're sharing, valence electrons between themselves and other atoms. But this is a one shape you would get. Another molecule, if we look at carbon dioxide, CO2, if you notice it has double bonds, and there's a reason for this. We have to look at, we'll look at in a few minutes. And then if you have SO2, if you notice it has double bonds, S in the middle, that's sulfur dioxide. You have a sulfur in the middle, 2 oxygens, and it's got double bonds, but if you notice they're bent. What causes them to be bent is because there's a lone pair of electrons around the central atom that are not being shared between the atoms of sulfur and oxygen, and it causes that to be bent. If we look at methane, that's CH4, carbon, also now called carbon tetrahydride. It's got a carbon in the middle, and it's got 4 hydrogens around it, and it forms, a certain shape that we see here. And we'll try to be talking more about molecules tomorrow and the next day. Now, what we want to talk about today is Lewis structures. And what Lewis structures are is a 2-dimensional way of drawing molecules. It's a way of drawing these on paper, and a way we can figure out what the shape of a molecule is just by drawing it out and figuring out where the electrons go. Okay, so the octet rule is, remember, most atoms form bonds in order to have 8 valence electrons. Now, valence electrons are the electrons in the outermost energy level. We've talked about those a lot. We can tell the number of valence electrons an element has based on the group number. Group 1 has 1 valence electron. If on the periodic table, group 2 or 2A has 2 valence electrons. If you skip over the middle, skip over the transition metals, you get to group 13 or 3A, they have 3 valence electrons. Group 14 or 4A has 4 valence electrons. Group 15 or 5A have 5 valence electrons. Group 6 or 16 or 6A has 6 valence electrons. Group 17 or 7A has 7 valence electrons. And group 18 or 8A has 8 valence electrons. You'll need to know that. You just go by the group number. So therefore, most atoms need to be surrounded by 8 electrons in a Lewis structure. That means the atom needs to be surrounded by that. One exception, though, is hydrogen. It only has to be surrounded by 2 electrons in a Lewis structure. And the reason for this is hydrogen only has 1 valence electron. It only needs 1 more for its first energy level to be full, so it only needs a total of 2 instead of 8. Alright, so this is the way we draw Lewis diagrams. First, you find the total number of valence electrons that's in the structure from all the different elements that make up the compound. You're going to arrange the atoms. A singular atom is usually in the middle. So if you have something like CH4, whatever only has one atom, like carbon's going to be in the middle, you know, this molecule with the hydrogens bonded to it on the outside. You're going to form the bonds between atoms, and then a bond is these straight lines, and they each stand for 2 electrons. So this would be 2 electrons, this would be 2, this would be 2, and this would be 2. That's all being shared for a total of 8 electrons there. And you're going to distribute remaining electrons as lone pairs. Lone pairs is going to be like around, you know, we'll draw them in like this right here. That's 2 lone pairs, or that's one lone pair, to give each atom an octet. And if there aren't enough electrons to go around, we're going to form double or triple bonds. So the reason carbon dioxide a while ago showed you had double bonds is because of you have to, the carbon in the middle has to be surrounded by electrons, so you have to form a double bond, and you'll see that in just a minute. Alright, so if we look at our first example, CF4, and we want to draw the Lewis structure for this. First thing I do is add up my total electrons. So I have carbon that makes this up and fluorine. Now carbon, there's one atom of carbon, so that's 1. And I'm going to multiply that by the number of valence electrons carbon has. Carbon is in group 14 or 4A, so it's got 4 valence electrons. There's one atom of carbon, so that's 1 times 4. It's 4 electrons. So carbon is going to bring 4 total electrons to this molecule. The fluorines, though, we have 4 fluorines, and we're going to multiply that by the number of valence electrons of fluorine. Fluorine's in group 17 or 7A, so it's going to have 7 valence electrons, and there's 4 of them. So 4 times 7 equals 28. And then we add these together to get 32 total electrons in this structure, whether they're shared or as lone pairs. Now, what we do is we're going to now draw our structure. We're going to draw right in our central atom. So for our central atom in this case, it's going to be carbon because there's only one of those. So I have a carbon in the middle. I'll draw it. And then it's going to be, I got 4 fluorines. I'm going to draw those as bonded to the central atom. So that is a fluorine there. Let's say a fluorine right here. A fluorine right here. And then one at the bottom. Now, each one of those lines stands for 2 shared electrons. Now, I got a total of 32 electrons in there. So how many have I taken care of in the structure? Well, I got 4 lines. These stand for 2 shared electrons. That's a total of 8 electrons that I've already used up in this structure. So I got to subtract that. 32 minus 8 gives me 24. I got 24 electrons left that I have to add in there as lone pairs. Alright, I'm going to have to add those in dots. Remember our rules is each atom needs to be surrounded by 8 valence electrons except for hydrogen. Well, if I look at this bottom fluorine, it's only surrounded by 2 electrons. It's got this line here which stands for 2 electrons. So this fluorine's only got 2 around it. It needs 6 more. So out of those 24 electrons, I could put 6 of them right here as lone pairs. And I've taken care of 6 of those electrons, so I have 18 left. I can go this next fluorine, it's going to need 6 around it. It's already got 2 right here with the line, with the shared electrons. And I'm adding 6 more. So now I've got 12 electrons left. I go to the next fluorine. I added 6 of them there, and then I have 2 more here. That's a total of 8 electrons around that fluorine. and I've only got 6 more left. I'm going to add them around the last fluorine. And I've taken care of all my electrons. There's no more to put in there. So the last step I have to do is check and see if it follows all my rules. Each atom has to be surrounded by 8 total electrons. So I look at this, I check the outside first, then I'll go to the inside. I check, this first fluorine here is surrounded by, we got 1, 2, 3, 4, 5, 6, and then it's got 8, 2 more right there. That's 8, so it's good. I check this next fluorine. It's got 2, 4, 6, 8. It's good. This next fluorine, 2, 4, 6, and then 8 right here. It's good. The last fluorine, 2, 4, 6, and 8 right here. So my fluorines are good. I just need to check my carbon in the middle now. So I check it, and it's surrounded by, this first line stands for 2, this is 2, this is 2, and this is 2 for a total of 8. So that structure is good. I don't have to add any double bonds. This would be the way I would draw it with those lone pairs. So as you see in 2 dimensions, all your lone pairs are showing around the outside. If I was to look at this molecule, what it looked in 3 dimensions, it would be like tetrahedral. You wouldn't see the lone pairs around the fluorines. You'd only see, if we had a lone pair around the central atom, you see that in our molecule, of our little out that we used a while ago to see the molecular shapes. Now my next example, if I have H2O, what would a molecule of that look like? Well, I got to figure out first my total number of valence electrons. So I have hydrogen. I have 2 of those times the number of valence electrons hydrogen has. It's in group 1A, so it's going to have 1 valence electron. So that gives me 2 total. 2 times 1. Oxygen, I got 1 atom of it. Multiplying it by the number of valence electrons that oxygen has. It's in group 16 or 6A. So it has 6 valence electrons. So 1 times 6 is 6. I add those together. There's going to be 8 total electrons in this structure. Next, I'm going to draw this out. Now, one of these is going to be a central atom, either hydrogen or oxygen. Since there's only 1 oxygen, I'm going to make that my central atom. And I'm going to bind my 2 hydrogens on each side. So that's H2O. Remember, these lines, these bonds I made stand for 2 shared electrons. So with this line, I'm taking care of 2 electrons. With this line, I'm taking care of 2 electrons. That's a total of 4. I subtract that from my total, and I have 4 electrons left that I'm going to have to add in there as lone pairs. Well, look, first, I always want to start on the outside, but if I notice hydrogen is my outside atom, hydrogen only has to be surrounded by 2 electrons, and actually it already is, because this line is 2 electrons. So this hydrogen on the right is good. This hydrogen on the left is good. It's surrounded by these 2 electrons. So I can't add them to the hydrogens. I got 4 electrons. I have to add those to the central atom. Because remember, oxygen's got to be surrounded by 8. And right now it's only surrounded by 4. 2 shared electrons on each side. So I add these in as lone pairs. And then I check it to see if it follows octet rule. Look at this first hydrogen, it's surrounded by 2, it's good. This other hydrogen is surrounded by 2, it's good. The oxygen in the middle is surrounded by 2 electrons here, 2 here, 2 here, and 2 here, for a total of 8. So that would be the correct structure of it. So if I looked at, because water has these lone pairs sitting around the central atom, I would probably think that the molecular shape of it in 3 dimensions would be like a bent. Instead of a perfectly linear molecule, it would be bent. Okay, now next example is carbon dioxide or CO2. So if I start with adding up my total number of valence electrons for carbon, I have one carbon atom. I'm going to multiply it by the number of valence electrons carbon has. It's in group 14 or 4A, so it has 4 valence electrons. So 1 times 4, it's got a total of 4 electrons that carbon brings to this molecule. Oxygen, I got 2 of those oxygen atoms. Multiply that by the valence electrons of oxygen. It's in group 16 or 6A, so it's going to have a total of 6 electrons, valence ones. 2 times 6 is 12. I add these together. 4 plus 12 is 16. So this molecule is going to have a total of 16, valence electrons associated with it. Now next I want to draw the structure. Well, look, there's only one carbon, so it's going to be my central atom. And then there's 2 oxygens, so I'm going to put them on each side like this, bond them together. And remember, when I bond, these lines each stand for 2 electrons. So I've taken care of 4 electrons so far. I got 12 left that I'm going to have to add in as lone pairs. So when I start to add these in, I look on the outside first, those atoms. I got oxygen. Oxygen, this first oxygen, if I look at, this one right here, it's surrounded by 2 electrons so far. It needs 6 more, so I can put 6 electrons there. So now it's surrounded by a total of 8. So I subtract those 6 from there. I got 6 left. I go to the other oxygen, and it's going to have 6 around it to have an octet. So I'll put 6 from around there. So I've taken care of all my electrons. I can't add any more dots in. Now I look to see if this structure follows my rules and if I have an octet around each atom. So I check the oxygen, first one on the right, it's got 2, 4, 6, and then these 2 shared electrons for a total of 8, so that oxygen's good. I look to the left, that oxygen, it's got 2, 4, 6, and then these 2 make 8, so that oxygen's good. Then I look at the central atom, carbon. It's only surrounded by 2 shared electrons there and 2 shared electrons there. So it's not following my rules. I'm going to have to do something. So when I get to this point, what I can do is take 2 of the, a lone pair of electrons from one side and form a double bond. So if I go and say this oxygen on the right, I can erase 2 electrons there, and I can form a double bond here. I can share those 2 electrons. Alright, so now check again my structure. This oxygen on the right has 2, 4. Just 2, 4, then it's got those 2 lines there stand for 4 electrons total, so that's got 8 electrons around it. The other oxygen still got 6 around it. The carbon now only has, it's got 2 here, 2 right here, 2 right here for a total of 6. So I can go to the other side and take 2 of those electrons that are, a lone pair and share those. I'll erase those and make another line here and share those 2 electrons. And then I check the structure. This last oxygen has 2, 4, 6, 8 around it. This oxygen on the left has 2, 4, 6, 8 around it. The central atom carbon has 2, 4, 6, 8 electrons surrounding it that are all shared between the carbons and the hydrogens. So this would be the correct structure, the Lewis structure for the carbon dioxide molecule. That's why it's got double bonds. So when you see the molecule, like in that, tomorrow when you do some work with this, you would notice that the shape of that molecule would be like that right there. And the reason it's got those double bonds is because we had to share some of those lone pairs around the auctions, and that way carbon would fulfill the octet rule. Now for this last example, NBR3, that is nitrogen tribromide. So nitrogen is in group, I have one of those, and it's in group 15 or 5A. So it has 5 valence electrons. 1 times 5 is 5. Br, I have 3 of those atoms, and I multiply it by the number of valence electrons bromine has. Bromine's in group 7A, so it has, or 17 or 7A, so it has 7 valence electrons for a total of 21. When you add 21 and 5, you get 26 total electrons. So next I want to draw this out. My central atom is going to be nitrogen, since I only have one of those, bonded by 3 bromines. So I'll put a line, share 2 electrons between that and bromine. Put another bromine here. Put the last bromine right here. Now, how many electrons have I taken care of? How many have I shared? Well, I got 3 lines there, so that's each stand for 2 electrons. So I've taken care of 6 electrons. So I have 20 electrons left. So I'm going to start around the outside, fulfilling the octet rule. And remember, hydrogen only has to be surrounded by 2, but everything else has to be surrounded by 8. So I look at the bromine on the right. It's got 2 electrons around it right now being shared. It needs 6 more, so I'll put 6 of them right there. And 20 minus 6, I have 14 left. I go to the bottom bromine. It's got 2 around it with this line here. I'll put in 6 right here. I have 8 electrons left. I'm going to go to this other bromine. It's got 2 already around it, so I need to add the other ones as lone pairs. And I still have 2 electrons left. And I can't add them anywhere except around the central atom. So I'll add them as a lone pair up here. And I've taken care of all my electrons. All I have to do now is look and see if it satisfies the rule. Alright, so bromine, this bromine on the right is surrounded by 2, 2, 2, and these 2 right here. So total of 8. So the bromine, got 2 there, 2 there, 2 there, 2 there. It's got around surrounded by 8. This last bromine, got 2 on that side, 2 there, 2 there, 2 there. It's surrounded by 8. And then I look at nitrogen. I got 2, 4, 6, and then I've added those lone pairs, 2 more. It's surrounded by 8. So that would be the correct structure, Lewis structure for nitrogen tribromide. So we would, expect that atom to, if we look back at our example here, there's not any like that, but that lone pair there would kind of push those bonds down. See the difference in that, and CO2 is a perfectly linear molecule because it doesn't have any lone pairs around the central atom. However, when you look at this one, it has lone pairs around the central atom, and it pushes those bonds down, and you get a bent shape, which affects its properties. Now, last thing, there's some practice problems for you to do. There's 4 of those. Once you're finished working these practice problems, you can check your answers with the PowerPoint.